I'm recording now. So, what we're doing today, we are going to be talking about. Now, we started about the topic on heat, and our topic name this topic is heat and heat and rate. How fast reactions are going. But at the same time, you also need to, just like when we watched the video last lesson, we talked about how if you increase the heat of the reaction mixture, you also will increase the rate of the reaction. So we're going to be talking about that. Now, so if you're going to be writing down notes, also you should be doing that. So our heat, and now we're not going to be talking about rates. We're going to be talking about reaction, heat of reaction. We're going to be talking about heat. We're going to talk about heat of reaction. Now, before we get started doing calculations and whatnot, you guys can read my handwriting, right? Mm-hmm. Okay. So before I started doing any major changes, I'm going to say this. I'm going to say all reactions, whether you're talking about chemical and physical, will either, you have two situations happening. You can either absorb heat from the environment. Yeah, reactions. Or they give off heat to the environment. Okay? So you have two of these potential situations. Either it absorbs heat from the environment, or it gives off heat to the surrounding or to the environment. I'm going to ask you guys, and you guys have learned this in previous years. What is the name for the ones that absorb heat? Anyone put up their hand, put up their hand. Yes? Endothermic reactions. Now, endothermic, and in some ways, it's easy for you to remember because endo, like entry, enter, so heat enters. Okay, heat enters. Ento. And if enter is endo, and then absorbs heat, what do you think the name for the reaction that gives off heat to the environment? Yes, exothermic. Thank you. Exothermic reaction. So exo, exit. Okay, gives off heat to the environment. Now, can you guys give me some examples of each? Can you give me some examples of exothermic reactions? Yes.
Coal burning.
What?
Coal. Burning coal.
Burning coal. So coal burning. So essentially, any kind of burning reaction, they are exothermic. But what's a fancy name for burning things?
Combustion.
Combustion. Okay, so all combustion reactions are exothermic. What else? What other examples of... Do you guys want me to write bigger? In the back row? Back row, yes, okay. So, what other examples of exothermic reactions? Yes?
When you come out of the pool, water evaporates and you get cold.
Okay, so you can say, this is actually two parts. When you come out of the pool, water on your body evaporates and then you feel cold. So in this case, is it an exothermic reaction? Is exothermic to who? That's interesting.
The person.
It's exothermic to you because, for example, let's just say I'm just gonna, I'm not an art teacher, so your body, you have water on you. If I have blue markers or blue, so let's just say this little bit of blue on you. That's the water from your body. I don't have a blue pen on hand, so that evaporates off. Okay, so essentially, your body heat go into the water, and then the water evaporate off. So to your body, okay, to you, that's exothermic because your body heat leaves from your body to the water. Okay, does it make sense? So to your body, you're giving off heat. You're losing heat to that water. To the water itself, do you think it's exothermic or endothermic? It's endothermic. To the water that was on your body, liquid water, now it goes from liquid, water as a liquid, going to water as a gas. It evaporates. It absorbs your body heat. So heat goes, absorb the heat from the environment and turning into gas. Good so far? Okay. So that is a good example of how these two things combine in real life. What else? Can you guys give me other examples of exo or endothermic reactions? Yes.
Exothermic, it's hand warmer.
Hand warmers, okay? In hand warmers. Hand warmers are actually quite interesting because the chemical reaction that most of the time they use is, if I believe correctly, is iron, and oxygen gives you iron Fe2O3. But they actually add other ingredients in there because if you think about it, hand warmer is warm enough so that you feel warm, but it's not like the reaction happened all at once in an instant. It lasts for hours. So think about all the heat that it gives off, and the reaction goes very slowly. Okay, if you think about how much energy it totally, like through the lifespan of a hand warmer, it actually gives off a lot of heat, but they controlled it. So the manufacturer have to do quite a bit of things, a lot of chemistry decision. What other examples of endo or exothermic? Can you guys give me endothermic reaction? Yes. Now, photosynthesis, it does absorb energy, but it doesn't absorb energy as heat. Okay, we're thinking about heat. I can think of one right now. Melting, true, melting. That's an endothermic reaction. Melting ice. That's an endothermic reaction. Oh yeah, I need to write bigger. So, melting ice, that's an endothermic reaction. Let me ask you guys this. We just came off from lunch. How many of you only ate salads and fruits for lunch?
Don't expect that.
What?
Don't expect that.
Don't expect you guys to eat only salads and fruits,
I
okay?
think we are.
So, okay. Hey Jin, what did you eat for lunch today?
Yeah.
Meat?
Yeah, Korean. Chicken, I think.
Korean chicken, okay.
And rice.
And rice? Amy?
I didn't eat lunch.
You didn't eat lunch, okay. Other people who ate lunch? Yes, Jessica?
Hot dog.
Hot dog, okay.
Yeah.
There was hot dog option, okay. Chris, what did you have for lunch? Okay. So, all these food are, did you eat it raw? I hope not. Yeah. cook food. Cooking. Cooking is a endothermic reaction. You put that chicken, barbecue it, I guess, I don't know. You cook the chicken, you apply heat to it. Okay? Cooking is a endothermic reaction because your food absorbs the heat from frying pan, oven, fire, whatever it is. Okay? Now, are you guys okay with this so far? Now, I'm gonna talk about. Now, one thing I like doing, usually, during the summertime, is I like camping. And when I'm camping, one thing I always like doing is having a fire. There's a point to this, okay? I'm not an art teacher. So, I usually like to have a fire. So, this is my drawing of a fire, okay? Now, you have a class, a lot of art students sitting right in the first row.
I'm gonna stare at you.
So, in this campfire wood burning situation, what kind of reaction is going on? Exothermic reaction. Exothermic reaction. And you have, it is combustion. Okay? From now on, instead of writing out exothermic or endothermic, I'll just start writing exo and endo. And with the other class, yes, some of my students were suggesting, why don't you begin the class with a big poster of the group EXO, which I do know about that group, but I'm not gonna do that. I can do that, but it doesn't show up on the screen. Okay. So, anyways. So combustion of wood. Combustion of wood, it is an exothermic reaction because all the heat gives off a whole bunch of heat to the surrounding environment. So heat, so sometimes I don't want you to think of exothermic, endothermic reactions as, oh, it's hot, it's cold. That's a lot of times not accurate because you have a body temperature of 37 degrees, so anything below that would be considered cold to you. So even though it might be giving off heat, it still feels cold to you. So it's not a good way to think about it. You should always think of whether something is an exothermic reaction or endothermic reaction by which direction is the heat going. So if you're thinking about the wood burning or fire as the system itself, you call this is the system that you're looking at. So in this case, it's exothermic because heat is leaving from the system to the environment. Do you guys follow so far? So heat in this case goes from the system into the environment. Clear? Now, also, when I go barbecuing, I like to grill meat. So, there's a grill, and on top of this grill, I have okay?
I'm assuming that's steak.
Yes, that's a steak. Thank you. That's why if your drawing skill is not that good, always label your diagram. Steak. Okay? So, steak. Now, if I look at, now keep in mind, I was talking about system and environment, and this is the very important points. So, if I'm looking at the steak that is on top of the fire, if I treat this as my system, so if this is my system now, steak getting cooked. Okay, if that is my system, is this an endothermic or exothermic? Endothermic. Where is the heat going or coming from? And where is it going?
From the fire
Coming from
to
the
the
From the fire or from the to the stake? Is it the system or the environment? No. You only look at the stake. This is where the tricky part comes in.
from the system.
You only look at the stake. So the system is just the stake. So in this case, the heat is coming from the environment. Because to the stake itself, they don't care about where the heat is from. It's not the heat generated from within, it's from the environment. Okay? So what I consider a system is what exactly I'm looking at and where is a chemical reaction taking place. Right now I'm looking at just the stake. Okay? The fire that's underneath it, that's the surrounding, or that's the environment. Do you guys follow so far? So in this case, the heat is coming from the environment going into the system itself. And because of that, it is an endothermic reaction. Good? Just like earlier, Josh's example of coming out from the pool, there's water all over him, and the water absorbed the body heat and then evaporate. So you also, even though the two things are very close to each other, his body and the water that's on top of his body, it's just right next to the other, you look at the system. So to him, if you're talking about the body itself as the system, so that is where the system is losing heat to the environment. So that is why it's an exothermic reaction. But to the water, when you look at the water as a system, well, the water is receiving the heat from the body and then becomes evaporated. So in this case, this is an endothermic reaction. Do you guys follow? Okay, so this depends. So because in real life, in chemistry, a lot of times you can't. We like to isolate things, but then at the same time, a lot of times you have chemical reactions that happens both next to each other, or a lot of reactions happening right next to each other. So you have to think about which system are you looking at, and that determines is it endothermic or exothermic reaction. It depends on your point of view. Good? Good? Okay. Now, I'm going to do a quick, to continue this lesson, I'm going to do a quick demo. At this point, is there a way I can pause this? No. So, tap here. But I can't. Okay, so I'm going to do a quick demo.